Oh, hello. May wait a minute if other leads will join or other.
Hello everyone, Yunjin from China Mobile.
Oh, hello, Yinjin. Welcome to the tag meeting.
Hello.
Thank you.
We may start in 1 minute. I think. Um, I'm not sure if there are other wants to join this meeting today. Until now, there's only one item in the meeting notes on our agenda today. So, oh, uh, Jamu and Yanjun, you may be new here, and would you introduce yourself?
Oh, sure. Hi everyone, Yanjun speaking. I'm from China Mobile Research Institute. I have participated in the CNCF community for years. Previously, we worked on the Commander projects and also LF, the Cuba Edge, etc. So we have proposed the topic around artificial intelligence for scientific discovery at the beginning of this year. So we would like to have an introduction of this initiative in today's meeting. So we are more than happy to have your advices. Thank you.
You're welcome.
Hello everyone. Can you hear me?
Yeah.
Okay, great. So, hi everyone. This is Jiamu speaking, and I'm also working for China Mobile Research Institute. And me and Yanjun are in the same group. We both work for the AI for Science working group of China Mobile, and Yanjun is also my supervisor and mentor. So I'm kind of new to this CNCF community, and previously my main works depends on the task the Yanjun assigned to me, and I worked some AI engineering programs and also some deep learning projects as well. So we're looking forward to exchanging ideas with everybody in this community. Yeah. Thank you.
Yeah. Thank you. Thank you for introduction. And I think there's already an open issue in the TOC repo about this since January, and I think Kant has already comment on the issue, and
No, I just show some interesting with this because we are also working on AI for science for a while. So I'm really interesting to and exciting to see this happen. So yeah.
Yeah, thank you for your advices.
So for this initiative, I'm trying. I haven't seen the issue, so forgive me if I'm asking trivial questions. So for this initiative, do you already have some white papers or some documents? What will be a basis for this project in the future?
You mean for the deliverable for this initiative or the background of
Well,
why
both.
we work on it? Okay.
Yeah.
So let's first have a brief introduction for the initiative first, a very short brief information. So why we propose this initiative is since the rising of AI applications, and we have find the artificial intelligence for scientific discovery has become more and more interesting, and we have seen some governments has released some strategy for improving this kind of platform to be produced or to be launched. So that's why we think it could be very useful for CNCF community to raise a topic around this kind of specific workload. And we could have a discussion on how to build a cloud native AI for science discovery platforms, including the patterns, the reference architecture, the needed functions, as well as maybe some gaps between the existing CNCF projects and the required functions. So that would be very interesting. So that's why we proposed this initiative. And I think the first output deliverable could be a white paper that we have a discussion on the requirements as well as reference architecture, and also maybe some functional analysis, including the gaps analysis, as I mentioned before. So that would be the first step. I think would be more than happy to see there are some following things we could work on after this initiative. For example, for the artificial intelligence for science agents, architecture, how to build this kind of specific applications, and how to monitor this kind of agents, including the traceability and as well as observability in cloud native systems. So that would be very interesting and useful to put in this public interesting topic in CNCF community. So we could have a lot of experts to work together on this. So regarding us, why? So me and Jama are both from China Mobile Research Institute. So why we propose this topic in CNCF? Actually, previously we are more worked on the cloud native resource management projects. So now, actually, China Mobile has a lot of different ways to explore their service that we can deliver to our customers. So we have set up AI for Science platform since 2 years ago. So it is a distributed cloud native platform that's located in different provinces in China. So we have a very basic platform that offer to the different research institutes and also to the universities in China. So we have received some requirements from different the science people, and also we have seen some very interesting issues we can work together. For example, normally the science workflow is quite complicated, including the data processing in between HPC system and AI system in between the GPU and CPUs, etc. Different kind of heterogeneous computing resources that we need to manage, and also we need to manage the workflow, transfer the data between those different systems smoothly. So we received this kind of requirements, and so we also think it could be a common issue that we can work together, rely on cloud native building blocks. So that's why the background why we proposed these initiatives in CNCF. So basically, this is the most important information for this. Yeah.
Additional question to that, as I see in the description and well, in what you just said, like there are a lot of overlaps with existing working groups. So, for example, like resource management at inside Kubernetes at SIG-Node and device management working group, like OpenTelemetry, it's the whole observability tags and so on. So I was wondering how this initiative going to or planning to cooperate with those groups.
Actually, I have the same concern here. Like, if we take a look at these projects, I think it's quite similar to like AI for machine learning or kind of that. So, what's the big difference here, like comparing to AI for science? Because, yeah, I think it's quite similar to Alex, I guess.
Actually, it's also our first the question that we rate this initiative. I think the most different things is regarding scientific workflow, or how to say workload, this specific workload, how we abstract these different workloads in to distinguish it between this very spatial needs regarding the general AI workflow, including the large language models, inference, or etc. So there will be very different patterns for the workflow because normally there won't not be the different ways or very complicated data processing for the large language models. The patterns are quite similar, but for the data flow for scientific, for example, for the protein structure prediction, you are processed on the, for example, the sequences of different the proteins. So you need the unique ways that to process the data before you put it into the large language models inference engines. And if it goes to another scientific fields, for example, the chemical inference model, that would be the different ways. So how to monitoring these different workloads in the whole, I want to say the whole end-to-end pipeline, because if you want to transfer the data if you want to monitor the data starting from the data processing, put it in the large language model inference and get the output or the loop maybe. So you need a way that you can manage all this workflow, give an abstraction to the different how to say the different value or keys that you can describe the different properties of this specific workflow. That would be quite different between what we are processing the large language models today, I think. So that would be a different things that we could discuss in this specific topic. And regarding the questions you mentioned about the for example, the observability or traceability, I think for sure we need to rely on a lot of the how to say, a lot of the existing building blocks of CNCF projects, that's for sure. But also we could give a reference architecture for people how to build up this end-to-end platform. For example, you were not facing the HPC system or maybe the GPU system together in one specific workflow for large language model workflow, but it's quite normal that you process the scientific data or you are processing scientific models. So I think it could be interesting that how you use these building blocks to monitoring the different systems status together and how to orchestrate them and how to give a visibility of all the systems, etc. So that would be the different things that we could trying to address that different with the large language models that we are discussed normally.
Do others have some comments?
As I mentioned, I don't have like really objections. I was just trying to clarify how it's going to be cooperating with existing working groups. Because like, yes, I understand the specifics of scientific workloads, but it overlaps a lot with whatever ours are doing already. But don't take my words negatively. Like I'm not objecting to the initiative.
Mm-hmm. Yeah, I think it's also very good comments for us if we really could set up this initiative as a sub-project, that we have a group of people working together. So how we could synchronize in between different different texts and think. So how the output can be transferred or synchronized in between different workflow. I don't know that concrete answer to be honest, but I think it could be very useful for the TOC or maybe the tech leads to give us some advices.
So my personal observation is for scientific workload, it will be domain specific because different scientific domains, even within the same domain, different type of applications will have drastically different profiles. So to understand what need to change, if anything need to change at all, probably need to classify the scientific domain and workload and what type of workload are there for each domain. I think that's the starting point.
That's very good. Excellent questions. You're right. There could be quite different for different scientific fields regarding the pipeline, regarding the models we used, regarding the ways we process the data. And I think you're right. So we only can give very general reference architecture or maybe general descriptions for the common issues or the common requirements in between those different scientific areas. For example, I think maybe processing HPC, so data processing HPC, or the data transmitted from HPC output to the AI system for the GPU resources for the large language for the models. So those topics may be common that will be faced for different scientific fields. So I think we could address on those common issues first. So we give some advices in between the how to say that different scientific fields may also have the issues simultaneously. So maybe we are not, for example, for the reference architecture part, we can't give a concrete architecture for each type of scientific platforms, but it could be very useful that we give some reference examples because we when we raised these initiatives in the TOC issue GitHub, we also received the comments from Ricardo from CERN, and he posted reference architecture that see in the end user working group, there's a type of reference architecture that give an example how they build the systems together. So I think it would be a very useful ways and a useful information that we could give some examples, the true examples, and how users can fields that build their systems. So that would be additional information we could cover in this initiative output.
Yeah, just to add on to that, I used to work for Oracle for a long time, so there are two from that, two thoughts from that. One is in the past everything is relational, right? So regardless it's scientific or not, and obviously in relational database world there's OLTP, online transaction processing, versus data analytic, data warehouse databases. And then of course later on, because for large scale analytics, non-SQL is more scalable, etc. Right? So I think they all come down to time, not the type of workload. Because I actually had this discussion recently. There's discussion about one of the project doing benchmarking for a large biotech, a bio research project. But it turned out the requirement is not make the large model, make larger model. It's actually make the model smaller, not larger. So it all comes down to the question to the scientific community: what problem are they having? Are they trying to run it in a large, huge terabyte or even petabyte database ecosystem? Or they're trying to run it on a small resource constrained device? That's the solution is totally different. But regardless of the problem, it's not the scale that is the main thing. It's the time, because the one scientist or even non-scientist run on Kubernetes cluster, the main criteria to see whether they have a problem or not is it fast enough for them to finish that workload on a Kubernetes cluster.
Yeah, you're right. I agree with that point. And also, I think another thing we are thinking about is besides the time, and see how fast that we could execute the scientific workflow. Another way is how smoothly we could execute this workflow. If we can build a smooth end-to-end system that people don't need to how to say, cut it down or to interrupted by human beings. So you need some breakpoints in between the end-to-end system. So if we could have some discussion like how to make this scientific workflow transfer in between different resource system that can make this workflow move smoothly without breakpoint. That could be very interesting as well. Because as I mentioned, one of the requirements we received is, for example, for the protein structure prediction. So they have a most of the time is not costed in running the large language model inference, but they are costed the time on the data processing. So when they are doing the sequence processing before going to the model side, the cost around, for example, 30 minutes to go. So for the model inference, it's around 7 minutes or even less than 1 minute. So normally scientific people choose to use HPC to do their data analysis, or use specific data analysis tools or system to work on that. And then they have the offline or the transfer, they have the offline backup the data from one machine to another, or maybe they have a unique tools that help them to transfer the data from one system to another. So it's not a very ideal ways for people to execute this scientific workflow. I think is for sure it's not the ideal ways in the future, including for the future, we want to make our model inference directly to the experiment machine to do the experimentation. We can orchestrate different hardware laboratory things, for example. So scientific people are thinking about end-to-end laboratories without people interacted. So that's why we think besides the time issues, how to use cloud native building blocks to play on this smooth work end-to-end system. It could be very interesting and also can show the how to say the visibility of this cloud native building blocks that can play in this field. Yeah.
Yeah,
So maybe
go ahead.
yeah, so maybe add on to Victor Lu about the speed. We are also doing some AI for science. We are doing like quantum algorithm discovery. So, so one important part about for this is the simulator, because you know, running quantum compute takes a lot of money each time. So usually we have to build a lot of simulator to first validate this on Kubernetes then cluster, and then we run this on the quantum compute. So I don't know if simulator is like essential part for most of the AI for science, but some user case from my side. So yeah, and also maybe was to add some use case in the white paper as well for people to understand, like what's the difference between, I mean, as I mentioned, there's a lot of projects are quite similar. So what's the difference between like AI for machine learning, AI for science, and then maybe it will be easier for people to understand, like, yeah.
Yeah, I think the requirement is actually very similar with AI science or not, because for example, agentic AI, the requirement, just like Yan said earlier about the required for reliability, right? So for agentic AI, it is also very important because compared with the traditional applications, you finish one step and go to the next step. If you fail in the middle, you either the system or the back, either the backend or front end will recover just one step. With agentic AI, you can imagine the task. You tell the agent, OpenClaw or whatever it is, say, do this task and create a system for me and continue from there and do a transaction for me. So there's no stop, right? So if there's a problem in the middle, the need to recover is quite much more complicated. So the agentic AI, when it comes to recoverability, reliability requirement is higher, and I would think that same regardless is for science or not for science. But definitely for science, because it's the data processing part, I think is probably the most differentiated part, because instead of doing like a transaction, either financial some or applications, scientific workload, typically you do a huge amount of data, because that's it's always doing research. So that's might be the biggest difference, amount of data and how it's done, more in batch rather than real time, I would say. Yeah, so there's a lot of interesting things can be discussed.
Yeah. I agree with that. And also, I want to add one more comments regarding the agentic AI for a scientific discovery system. And one thing would be also very interesting is how we can integrate different types of AI tools for this agentic AI system for the scientific discovery. So there will be some of the tools may be feasible. I mean, easy to be integrated with existing agents system, but some of the simulation tools might not be. So we are also very happy to see if some real examples that the people work on different areas can give some comments or maybe give some feedbacks on how to move forward for the next agentic AI system regarding some typical simulation tools that are used but not able to be integrated in our agent system today. Yeah, that's one little comments for that.
Yeah, I think as other mentioned that the scope may be we need to make a clear scope for this white paper maybe, and also for the first step, I think we may start with some draft or a clear plan. I'm not sure if when will be the first minor version, which will included in the first version of the paper, and maybe we can get some feedback like the theme or other case study, so we can get some feedbacks or a clear scope later, maybe the draft review or case study collection.
Yes. So your Paco, you say that we need a draft version for this initiative white paper, or you are asking about the time when we could give this draft outline of this white paper. So
Yeah, maybe an outline may help, I think. This
okay.
is only my opinion to make some process about this.
So by the way, is this white paper, I mean, already there, or is still haven't been started yet?
I think it could be. I think we haven't officially started, so we just give some introduction on the TOC GitHub, saying around the background and also the scope. But the scope is still quite how to say is a big scope. So I think it'd be valuable for just as Paco suggested, we could give a detailed outline, maybe including the architecture of this white paper. So which technical things we want to discuss in the first version, or if some use cases will be included as well. That would be, yeah, that would be maybe better for us to move forward.
Yeah, great.
And also, I think I have a suggestion from Kevin said for the initiative white paper, it's should around 5 pages. So also we are thinking about if we need to narrow down the scope, since quite currently the original proposal for this initiative, the scope is a little bit ambitious. So I'm not sure if we could have it all the things covered within 5 pages. So maybe we could have some scope adjustment for narrowing down and maybe cut them into a different topics in the future. For example, the AI for science agent engineering stack, it could be a very isolated topic that we can deliver another white paper. So we are thinking about your suggestion, Paco. So maybe I don't know if we are back to worked on the draft outline just by ourselves, or we have some sub-working group or working group that we can have a discussion together. So normally how we move on for that.
If I remember correctly, for the AI scheduling white paper, they have started long time ago, and they have a draft first, I think, and later discussions are based on that, and there's a regular meeting for the white paper review and steps forward, something like that. Yeah.
So
I
okay.
just saw Rin has raised his hand. Maybe he can
Oh, sure.
introduce about the TAG chair elections.
No, I just want to continue. So thank you for raising the 5-page limit. So if you want to get your paper published, I would strongly advise keep to 5 or under, and rather, because things in AI is moving so fast, rather publish short outcomes on specific topic, very concise, and follow up with more topics as the field move. From other groups that I saw, specifically AI type papers, they're stuck for months because they just went too far, did too much in one paper, and the work that they're frustrated because the work that they've done is actually busy expiring and being replaced by other work. So yes, if you move fast, short papers, and rather have follow-ups after that, that will get you published faster. And then the other thing that I would also recommend is your tag have their own TOC liaison, and incorporate the TOC liaison into, I was just about to look who's your liaison, I can't remember off the top of my head. Incorporate the liaison in your process and say, this is what we're going to write about, this is how long we're going to do, this is the timeline. Are you on board? Because that would be the first person to review and get you published fast, because every faster, shorter is better at this stage.
Okay, thank you for your comments. Yeah. And so definitely we want to have our scope narrowed down so that we can have a short white paper for the first step. So to be addressed on the specific things. So, and maybe we could have continuous topics worked on this big area, artificial intelligence for science, but definitely for one white paper, we could start from a short one.
Yeah. If there's no more comments on this, we may go to next topic. Is there other? For the talk related, there's some new projects review, tech review, open issues. If you are interested, you may help in those project tech reviews. And Ren, do you want to introduce about the tag chairs and tech lead nomination schedule? Or
Yes, I can do that. And I quickly looked at your liaison. So at the moment, your liaison is Kevin, the co-chair of the TOC, as well as Alex Cherkop is the other liaison. So reach out to them, but also keep in mind there is an election for the TOC also going on, and you might have a shift in your liaison. Just make sure. Okay, about the election for the TOC, for the TAC leadership. As you saw in the Slack channel and in the mailing list, there is an election coming up for the leadership. With the change of the tag structures end of last or middle of last year, we changed or we asked some of the tag chairs and tech leads to stand for only a 1-year period. And the purpose of that was so when we have an election, everybody don't get replaced at once. Going forward, everybody that get elected will have a 2-year period. And so we already now have a staggered pattern. So every year there will be election, and it's only some of the leaves get replaced every year, ensuring continuation across the multiple years. So then also anybody that is up for election, you are more than welcome to stand again. There is no limitation, and the purpose of the election every 2 years is to allow people life change, responsibility change, jobs change. So you have the option to gracefully step back and let other people nominate themselves if you don't have the capacity. But if you do have the capacity and you've got ongoing work and you really want to continue, you're more than welcome to have yourself nominated again. The nomination issues will be published in the TOC repo next week, Monday, and then you can just fill in your nomination like we did in the previous rounds.
So is it nominations only for TOC, or it's also for our like chairs and tech leads?
No. TOC is almost finished. Their election actually finish up at the end of on Monday. Their election finish up, and some tag chairs are standing for TOC. That's why we're staggering it. So once we know who's on the TOC, we know who need to be elected. So the election nominations for TOC chairs start on Monday, and then you'll see once the chairs are finished, right after that, we're going to open up the election nominations for tech leads, because it could be that some tech leads want to move up to chairs. Do not confuse the whole situation. So we first do TOC, which finish on Monday. Then we do the chairs, which runs for about 4 weeks, 2 weeks of nomination, 2 weeks of election. And then right after that, we're going to have the tech lead nominations and election, and we should finish up early in July with all the elections.
Okay, because when I misread the message, I had the impression what were tag chairs and leads when the election nomination will be open at like end of May or something. Okay, I'll double check the dates.
Yes, in the Slack channel for the leads, there is a schedule. Let me just go find that quickly, and I will give me a moment. And also, if you look in your mailbox, you should have, if you're on the mailing list for chairs, and also in the TOC channel. So let me go through the schedule quickly. So TOC election will finish, and they will be seated on Monday the 11th. Nominations open for chairs. That close on the 26th of May. Then we start voting from the 26th of May till the 8th of June. Then we will announce the new chairs. And then the 8th of June, we're going to open up the nominations for the tech leads. That's going to run until the 22nd. Then the election for all the votings will start on the 22nd. And that will close on the 6th of July. Then we will announce the tech leads.
Okay, yeah, I misread about tag leads and tag chairs and tag technical leads. Okay, thanks for clarifying.
If there's any other questions, you know where to find me in Slack, and reach out. I can help you with that.
Thank you. I'm not sure if there anyone has other topics. I think we have a lot of discussions around the AI for science here, and maybe we can take some action items after the meeting. And yes, thanks Yanjun and Jamu for your introduction about the white paper things and everyone's comments.
Thanks for today.
Thank you. Thank you for all your comments today.
Thank you, everyone.
Thank you for coming and presenting.
Have a great day. Bye.
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 Thanks everyone.
Thank
for
you.
listening
Bye.
to.